So we are in causal inference in statistics, and we are down in chapter 4, question 4.5.1. And the previous several videos have been exploring using counterfactuals in some very interesting contexts. And among those contexts was trying to understand the probability of necessity, which we'll touch on again here, and also some related types of probabilities like the probability of sufficiency and the probability of necessity and sufficiency. Okay, so and so most of the previous videos here, or several videos, have been just examples that are in the book, and hopefully I've tried to hopefully I've been able to add a little bit of context compared to what the book walks you through. But now we are actually confronted with a question that we have to figure out. Okay, so here we are going back to example 4.4.3, which we did a video on way up here, and here I've just copy pasted the setup there, and so let's go back over that setup. So we have two women. So there's Miss Jones, two women that have cancer, and they're facing different treatment options. Miss Jones, well, okay, sorry, sorry for the back and forth. Okay, so we have two women that both have cancer, and they're both presented with two options for treatment. One of them is to just receive a lumpectomy, and the other one is to receive lumpectomy plus radiation, or irradiation as it says here. Okay. And so one of them, Miss Jones, received both lumpectomy and radiation, okay? And at least out to 10 years, she has not experienced recurrence. Okay, so she is still in remission. On the other hand, Mrs. Smith opted just to have lumpectomy, and after a year, she had recurrence. Okay, and so now it's kind of our job to determine whether or not their respective outcomes are due to their respective decisions as to whether or not they received radiation in addition to their lumpectomy. Okay, and so the problem kind of prompts us that says there's some additional data compared to that was available in 4.43, but really it's just giving us some additional information so that we can apply these bounds on the probability of necessity, and in the, I think it's just the exactly previous video to this, we kind of looked at where these bounds come from. Okay, but here we have the expression that the book gives us. Okay. So the question specifically asks about Miss Jones, and so now again, Miss Jones is the one that had lumpectomy plus radiation, and so she wants to know, should she attribute her remission to the fact that she had radiation? Okay, so the question, like I said, asks about Miss Jones, but we will also consider way down here. We will also consider Mrs. Smith, but first Miss Jones. Okay, so remember that our expression for the probability and necessity is this guy right here. So we want to know what is the probability. Oh, yeah. Well, let's first say what x0, x1, x0, or y0, y1 mean in this context. You could flip these around. And also, as we go through this, please make sure that I have not accidentally halfway through transposed what these definitions are supposed to mean. That would be very, very easy to do. Okay, but we're going to say that x0 means no radiation, in other words, lumpectomy only, and x1 means that they additionally receive radiation. Y0 means no remission, so in other words, recurrence, and y equals 1 means that they achieve remission. In other words, no recurrence. Okay, so those are the ones that I think will become a little bit confusing to keep those straight. But okay, so the probability of necessity then is what is the probability that the outcome y is 0 in other words, recurrence or no remission, if the treatment had been 0, in other words, lumpectomy only, given that what we actually observed was that this person received radiation and experienced remission. Okay, so that's what we're asking then. All right. So from the available data, we know these probabilities right here. Okay, these are just given to us. And so now we need to plug these in to our expression for the bounds on the probability of necessity. Now, this is the notation that's used in the book, and that's fine. But I'm going to use the notation that we were using in the previous video where we were deriving these things. But this is an equivalent expression to this up here. Okay. So we're going to try to fit these probabilities into this big expression right here. Okay. And so you can, I don't think I'll walk through exactly how we did all this, but we just fill all of, we put all of these things in here. Okay. I think that you should probably march through all of this to see how I've done this, and secondarily to make sure that I have not made an error, which again would be very, very easy to do. And when we get all the way done with it, we have these bounds right here. Doesn't really highlight very well. Okay, we got these bounds right here, where we have this joint probability that still remains unsolved. Okay. Now you might imagine that any data set would automatically have these things available, but this one doesn't. And so we're going to have to calculate it given what we have right here. So this is just an inconvenient thing about the problem, but that's fine. Like I said, normally I would imagine that most data sets would have this for us, or something very easy to estimate, but we don't. So we can calculate that with this lot of work right here. Okay, so again, I won't go through every single step here, but I think that the key thing to recognize is that we can rewrite a joint probability as the product of a conditional probability and maybe we call this a marginal probability or something like that. And then we just push through, and sometimes you may need to pull the trick where the probability is 1 minus its obverse if we have that the obverse at our disposal to use. Okay, so anyway, you should push through all of this, and if I have done it correctly, then we have that the joint probability and what is equals to 0.91, and where again we want the joint probability of y1 and x1, where y1 is that they experienced remission given that they undertook radiation. Okay, so our final expression then for the bounds on the probability of necessity is right here, right here, good enough, and and we can simplify these things to about here. Okay, so what are the bounds for the probability of necessity for Miss Jones? Well, they're somewhere between about 10 and 20%. So, in other words, it doesn't really seem that in Miss Jones' case that she should ascribe her remission to the radiation. So there you go. I'm a little bit suspicious of my answer here. Like maybe I made a mistake, but I cannot find one. So if you find one, please tell me. And the reason that I am suspicious of it is because I imagine that when they were setting up this this example, it would have just been more intuitive for them to say, yes, radiation was a good idea. That just seems like the intuitive thing to do. And so I can't imagine that they were trying to make a point about radiation therapy. I think they would have just gone with their guts. And so this seems a little weird to me. But if I haven't made a mistake, then that's the answer. So do please check and let me know in the comments. Okay. Now, so that was Miss Jones, who again experienced remission and undertook radiation. And so now we're going to ask about Miss Smith, even though the question doesn't ask about Miss Smith. So now we're asking not about the probability of necessity, but instead the probability of sufficiency. Okay, so more precisely, what we're asking is, what is the probability that Mrs. Smith would have experienced remission had she undergone radiation therapy, given that she did not undergo radiation therapy and did not experience remission? Okay. So instead of doing the bounds, I mean, in the previous video, we definitely give bounds, right here for the probability of sufficiency. And if you recall from there, the reason that we have bounds is because there is this probability that we cannot estimate the probability of prevention. So if I'm speaking nonsense right now, then you should go watch that video. But if we assume that radiation never prevents remission in this case, then we can drop that term, and then we get just a finite, not a range, we get an exact number for the probability in here. So we're going to use this expression for the probability of sufficiency. So if we go down here and we plug, the values in that were given from the problem, then we get that the probability of sufficiency for Mrs. Smith is about 64%. Okay, so in other words, in the case of Mrs. Smith, there's a greater than 50% chance, there's a 64% chance that radiation would have, helped her accomplish remission. So in Mrs. Smith's case, it seems to be the case that her regretting not doing radiation is justified. Okay, so we'll call that good.